we are thinking wrong about Bitcoin soft forks. At least that's what the guest of today's interview, ReardenCode, says. This is by far the most technical podcast I have ever done on Bitcoin Season 2. I invite you, the listener, to try to hang on as long as possible. We do introduce a lot of very obscure technical topics, but I think you will find some stuff worth listening to. We do talk about opcat, MEV, and Reardon's preferred soft forks going forward. Bitcoin Season 2 is brought to you by Arch Network, the platform powering bridgeless apps on Bitcoin. More on Arch later on in the show. Let's kick it off. All right, ReardenCode. It's great to finally have you on Bitcoin Season 2. Welcome to the show.
I am so pumped to be here with you. Yeah, listen to your stuff. Love it.
We've talked a lot on mainly X or Twitter, but for the listener who's like not deeply immersed in the Bitcoin developer world, there will be parts of this conversation which get too technical to follow. But I'm going to challenge Reardon here with at least starting off with some building blocks to better understand Bitcoin so we can talk more deeply about it. So Reardon, you're an independent Bitcoin dev, freedom advocate. I want to ask you, I think this is maybe, it may come across as a boilerplate question, but it does actually impact how you think about Bitcoin. What do you think Bitcoin is, and what should Bitcoin be?
Well, I really push against the should part of that question. But in terms of what Bitcoin is, Bitcoin is the first ever digitally scarce thing. And that was the 0 to 1 of Bitcoin, that when whoever Satoshi was, when he was developing Bitcoin, he realized that by creating a system with certain properties, decentralization, immutability, proof of work to secure that immutability, all the properties that Bitcoin has that we kind of all know and talk about, that created the first ever digitally scarce thing. And so that's what Bitcoin is. And in order to maintain that specific is property, it is digitally scarce, that requires that it be sufficiently decentralized. And that's where you might get me towards a bit of a should, is that we should do whatever we can to maintain that decentralization, because without that, we lose the fundamental property of Bitcoin of digital scarcity.
This episode will come out the week of our Bitcoin scaling conference, opnext. And you will be talking about a topic which will kick off right now, which you say that the framing around opcodes should be improved. Now, for the CoinDesk listener who stumbled in to this, that phrase might be very confusing. Let's try to talk through this linearly. Maybe what is an opcode? People have heard opcat or opctv, but what's an opcode first of all, and what does this do in Bitcoin?
Yeah, so I think to do that at the right level, we're going to have to go back pretty far, which is fine. I think it's helpful for everyone to be reminded. So Bitcoin, we often think of Bitcoin as being secured by signatures, and that's the most common way to use it. Now, an interesting thing about Bitcoin is that until Bitcoin's Taproot soft fork in 2021, all Bitcoin was actually secured by scripts. And most of those scripts included at least one CHECKSIG opcode. So now we're getting to tie into the opcode you're asking about. What is an opcode? Well, fundamentally, again, before the Taproot upgrade, every Bitcoin UTXO, unspent transaction output, was secured by a script. Almost all of those scripts include a CHECKSIG opcode. But there are other opcodes in Bitcoin. Notably, we have time checking opcodes, check lock time verify, check sequence verify. We have addition and subtraction and if and else, and kind of some basic scripting opcodes that people who do programming will kind of recognize. They're familiar to programmers. But again, most Bitcoin doesn't use most of those. They mostly just use two opcodes, really, hashing opcodes and check signature opcodes. And then with the Taproot upgrade, in the case of the key spend Taproot, we don't do opcodes at all. It's just an automatic signature check. It has the same functionality as the CHECKSIG opcode, but it's not an actual opcode anymore. And then within scripts, we are now thinking about adding opcodes, and that's kind of the whole context of the conversation. Opcodes let us restrict the spending of Bitcoin using these scripts in different ways. To give an example, the Lightning Network depends on those time locking opcodes that I mentioned. You have to have the ability to say, you can't take this next action until some time. That's how the Lightning penalty feature works. So that's an example of an opcode, is the time checking.
Where a lot of the current software discussion centers around which opcode should be added to Bitcoin Next, or which suite of opcodes. Again, for the listener, like an average listener, they may have heard of opcat. Like that's kind of the popular normie one. Comes with an NFT collection, ordinals collection. It's great. It's fun. Whatever.
I hate them so much.
Yeah. Well, that's for another conversation. But a lot of the developer discussion has looked a certain way, and like a lot of the discussion of like, should we add these opcodes, you argue has maybe been framed incorrectly. I want to maybe start out by saying how it has been framed, and then give me a high level of like how you think we should start framing the discussion around these.
Yeah, so I think there's been a lot of talk, and I've participated in it. Just to be clear, like this isn't me throwing stones or something.
Guilty of of contributing to this.
Yeah. Yeah, so we have this talk, we make like maps. Okay, this opcode enables these things. So like, I want lightning symmetry as a classic example. I want vaults. I want this, that, the other thing. And we say, this opcode gives me, or these opcodes give me this feature that I want. And the problem with that is that for any given opcode, there's some set of capabilities it adds to Bitcoin. And then every protocol needs some capabilities. And when we're talking opcodes to protocols, we're skipping that in between. This is not my idea, by the way. This is at Nothing Much on X, Yuval, and he and I had a long conversation about this, and I realized he's totally right. A big part of the challenge in talking about what soft fork should we do is that we're skipping that in between state, and so then you're always asking, well, what protocols can I get from these opcodes? But by skipping the capabilities, you're kind of missing, well, what else does it enable that's additional? And maybe I don't want everything enabled at once. And so by inserting that in between level, we can say opcodes enable capabilities, protocols require capabilities, and capabilities enable protocols. And that conversation, that kind of three-part conversation, it gives us a better ability to decide what might be the right steps to take in upgrading Bitcoin.
Yeah, tease this out for me a bit more. Like you say, we should talk about an opcode and what capabilities it enables. Dive deeper into this. Like you've come up with some examples, and maybe look empirically towards Bitcoin's history for how to like discuss and describe what you're talking about.
Yeah, so the easiest ones are opcodes that give exactly one capability. So we'll talk about the historical opcodes. Check lock time verify enables exactly an absolute time lock. It doesn't do anything else. From the time that UTXO is created, there's an absolute time until it can be unlocked. And that's the only capability that's really added with that. Similarly, check sequence verify enables exactly relative time lock. It doesn't do anything else. So those are kind of the simplest types of opcodes because they do just one thing. Check template verify is in that category. Check template verify enables exactly predicting or locking to the next transaction that'll spend this Bitcoin. And that's one capability. That's all it does. That specific capability happens to, well, actually all of those enable several protocols, right? Lightning is possible because of those time locks. Payment pools with reduced coordination are possible because of CTV. So there's plenty of things you get with just a single capability. When we look at something like opcat, because of some quirks in Bitcoin, enables several capabilities all at the same time. Opcat enables limited multiplication. Bitcoin doesn't have multiplication right now, but opcat gives it that. Opcat enables introspection, meaning that you can use within your script, you can look at what transaction is spending this Bitcoin and inspect or introspect the transaction doing the spending. Opcat enables deconstructing hashes in general. If there's a hash provided, you can use opcat to take the pieces out of that hash by requiring the spender to provide them. And so opcat ends up being this many capability opcode. And that's why many people like it, actually, is that with a single opcode that only has, as people like to say, 10 lines of code or whatever, we get a bunch of capabilities. And I think talking about it in terms of those capabilities actually helps to clarify. And I realized, again, when I was talking to Yuval, that this is how I've been trying. I've been like struggling to find the words to talk about it that way. Because people say, oh, opcat's the everything opcode. And I'm like, no, opcat does these things. And I was talking about capability without realizing it. And so that's what we're talking about here, how opcodes map to capabilities. Some do just one thing, some do many things.
That's interesting because you talk about like there was a point where you were you're talking around this and you're trying to communicate this mindset, but you didn't quite have the language or these definitions around. You're talking about capabilities. When did this happen? And then how has that guided how you talk about soft forks and these opcodes in general?
Yes, I think I had that long talk with Yuval maybe November. It was in the winter. I don't know.
Yeah.
And I haven't done as much work as I wanted to this year, frankly, on Bitcoin. But I've certainly been trying to frame my language more in that way of, okay, what capability do you need for this protocol? And an example of that came up. I had a brief talk on X with T-Bast over at Async, and he was like, I really want an opcode that does this. And I'm like, okay, what capability does that even mean? And it turns out that, and this is the kind of the other thing I want to talk about in my talk at opnext, it turns out that he was looking for basically a magic wand, right? He didn't have a concrete mapping to a capability. And so it was impossible to answer, here's the opcode that does this, because we didn't even know that the capability he wanted was possible. And I think it actually, putting an intermediate step makes it more clear that this thing may not even be possible. And then once you can define the capability you need, then we can start looking, can we write an opcode that does this capability? But if you just start from, I want an opcode that does this, you're skipping that middle thing, and you're kind of just keep throwing things at it. Does this one do it? Does this one do it? And you're not making progress. With the capability talk, you can say, okay, figure out the capability, then figure out the opcode that does it.
So you're saying maybe like the soft fork discussion begins with asking what capabilities we want, and then working maybe even backwards to look at the existing opcodes?
Yeah, or potentially to design new opcodes, right? And that's really, I think, one of the key parts here is we have a bunch of opcodes that people have already written, myself included. They might not be the right ones because they might not create the correct overlapping set of capabilities. I can't necessarily answer that, but once we know what capabilities we want, then we can answer that question.
So let's dive into some of the capabilities and maybe of like the prevailing popular opcodes out there. And this is where, if it already wasn't too technical, it might get even more technical. Apologies to the listener, but this is one you can kind of bookmark and maybe come back to and chat GPT or just DM Reardon all your actual questions.
Yeah, DM's open. I love talking about this stuff. It's my hobby and my profession. So
yeah. Okay, so let's start with the let's do historical first, because I think I think in a message to me you said what was it, that if we go back to SegWit 2017, that enabled one capability, which was non-third-party malleable transactions. What is that, and why? This might be a dumb question, but why did SegWit not enable more capabilities than that?
Yeah, so I draw a distinction, and I've been doing this a bit on X as well, to answer the second question first, between capabilities and optimizations. In some cases, Bitcoin already has a capability, but it's too expensive to use. And so that's a case where you may not be adding strictly a new capability, but you're optimizing an existing one. And SegWit did lots of optimization. So SegWit optimized the signature hashing modes so that we didn't have to be as protective of how many signature hashes we did per transaction. SegWit reduced the cost of signatures, so some multi-signature protocols became cost-effective that weren't before. So SegWit did a bunch of stuff, but in terms of the fundamental capabilities of Bitcoin, the only fundamental change was that you now had the option of having your transactions, once signed, be impossible without your secret key to malleate by a third party. And that is something that is important for off-chain protocols. If you have an off-chain protocol, a lot of times it depends on the ability to chain one transaction after another. And if a third party can come in and change one of those in-between transactions, they can break the chain. And so that's why non-third-party malleability was such an important capability for Bitcoin. There were many conversations before SegWit about how best to accomplish that. And I think it was Luke Dasher and Peter Wooler who came up with the SegWit method of, we can either whack a bunch of moles with a hammer, which is what I think Bcash has done to get rid of third-party malleability, or we can do SegWit and kill it all with one change. And that was very important to the ability to build off-chain chained transaction protocols.
And then we get to the most recent soft fork, Taproot, which you said enabled two capabilities: multi-party computation and hidden script paths. What are those to the average user? I know I see a lot of custodians advertise their MPC protocol. Is that what that enabled?
I wonder, thinking back on it now, if I should have called those optimizations, because there are these custodians that currently do MPC on ECDSA. So just to give a little context on that, ECDSA is elliptic curve digital signature algorithm. And that was the method that Bitcoin used for signing transactions when it first came out. Ethereum also uses it. Many things all over the internet use ECDSA. There is another signing algorithm out there called Schnorr. Schnorr is more of a category of algorithms. And so then Bitcoin in Taproot switched from ECDSA to a Schnorr algorithm called BIP340 Schnorr. That change took the complexity of doing these MPC multi-party computations from something that required, depending on the one, 3 to 10 round trips between the parties and required many layers of cryptographic assumptions, to being able to do multi-party signatures with just 2 round trips between the parties, in some cases optimizable to 1, and not only fewer round trips, but also no additional cryptographic assumptions beyond what Bitcoin already has with its signing. So it significantly optimized it to the point that I'm pretty comfortable calling it a capability. Like, you couldn't do provably safe multi-party computation, and now you can do provably safe multi-party computation, I think is a step change, a capability change. I'm open to the argument, though. So that's thing one of the new capabilities in Taproot. And then, and I want to dive a little bit more into that on why that matters. Why is that important? Right now, the reason that people like Coinbase advertise their MPC capabilities is because that enables them to secure their users' funds with many keys that have a combined total set of security properties between those keys that gives them a dramatic increase in security versus having a single key, or even a Shamir's shared key where they bring all the pieces together to sign. They're able to provide extremely high security that way. And so by reducing the complexity of that type of MPC operation with protocols that are now available like MUSIG2 and Frost, now many more people without using proprietary MPC work can now provide that same level of security to their users at a dramatically reduced cost compared to using on-chain multisig. So I think this does really matter, and we're going to see products really leveraging it kind of in the next few years. I know Ledger just released firmware that supports MUSIG2. I know FrostSnap is a hardware company working on Frost-based MPC for Bitcoin hardware devices. And because these protocols are so much simpler than the MPC like at Coinbase, they can be done on little handheld devices. And again, this is how I call it a capability. It really changes it. It goes now from being a commercial-only thing to being available to every user to get this MPC functionality. So I think it does matter.
Let me tell you about one of the most slept-on opportunities in crypto. Arch is building fast, composable DeFi apps on Bitcoin. Arch apps tap into the OG blockchain with by far the most liquidity and best brand in crypto. I've known the team for over a year. The tech they're building is solid, and they are racing towards mainnet. There's dexes like Saturn, meme coins on FunkyBit.fun, instant loans on Cha-Ching, and so much more. Plus, they're rewarding testnet users, so join me in trying out Arch while it's still early. You touched on a couple topics. One, which is moving some of the core capabilities of Bitcoin from the commercial to the average end user, and then also, I forget where I was going, but you have also hidden script paths in Taproot, which again, that's something I'm still kind of wrapping my head around. What's funny is I think I know this best from the perspective of ordinals and understanding how these things work by how they affect my JPEGs. But what is that?
Yeah. So the simplest way to think of it, and the unlock that's worth calling a capability, is just call it privacy. With Bitcoin before Taproot, when the Bitcoin was spent, it was always necessary to fully reveal what spending conditions were possible for that Bitcoin. So you had some Bitcoin locked, and it could be spent either by yourself or by, let's say, your wife and your lawyer combined. And that was the conditions you had. When you spent it yourself, before Taproot, you had to tell everyone, oh, my wife and lawyer also could spend it. I mean, it wouldn't have their names on it, but the keys would be there. It would show, oh, there's a 1 of 1 or a 2 of 2 in this spend. With Taproot, for the first time in Bitcoin's history, you can spend Bitcoin and only reveal the spending path taken. And that is a fundamental change. And that's what script paths enable. The details of exactly how those work with control blocks and hash trees and all this stuff are not as critical as the fundamental thing of you can spend the Bitcoin and only reveal the spending path you took, not all possible spending paths.
Okay. So that's where we've been over the past, gosh, I'm looking at my cat, 8 years.
8 years. Yeah.
Yeah. So yeah, 8, you might even call it just a decade's worth of softworks, which is 2.5 now, I guess. So we are sitting here. You and I have been prominent voices trying to talk about what the next soft fork looks like, and now we have, and you're here saying, here's how you think it would be productive to start framing these discussions. Now we have I just self-identifying the front runners being this combo of CTV and CHECKSIGFROMSTACK, CTV and CSFS. And then we have CAT. And sometimes these are combined together in a trio of opcodes. You have others. You've authored lenhance, which is, got a couple of those in it. And so like, let's look at the menu of different like prominent proposals out there, and I will just like invite you to go through each of these and talk through what capabilities they unlock. Let's start with CTV and CHECKSIGFROMSTACK. I understand this is more narrowly defined. Can you talk about what narrowly defined is, and then what capabilities does CTV and CHECKSIGFROMSTACK unlock?
Yeah, so starting, I think we mentioned earlier, CTV is a nice one capability opcode. It enables locking the next transaction that'll spend some Bitcoin. And one thing that I want to remind everyone about is because Bitcoin is a scripting-based system, and also because of Taproot with these hidden script paths where only the alternative taken is revealed, people hear, oh, it locks the exact next transaction. They're like, well, why would you bother doing that? So I want to just remind everyone, it can lock the exact next transaction under certain conditions. For example, it could be, this Bitcoin is locked to my key, but after 5 years, it can be spent to this exact next transaction, which maybe is a key that I had stored away somewhere difficult to access, right? So there's a lot of ways you can use CTV, or you could even do like, after 10 years, if I don't spend it, it's distributed to these 10 people, of which I think some will still have the keys, right? So you can use CTV by pre-locking the next transaction under some condition to develop more flexible, both like inheritance or recovery or other things with your Bitcoin. And when you combine that with Taproot, where you don't have to reveal that path unless it's taken, you get this, I think, very cool set of protocols, again, capabilities mapped to protocols of, oh, I have just my regular single sig wallet. It's just a regular hot wallet from on my phone. But if I lose that key, somewhere hidden in the script paths, there's a way to use CTV to recover that Bitcoin, all of it or some of it. So that's CTV kind of in a nutshell, is that kind of thing. You're going to lock the next transaction for some reason under some conditions. As a result of that, can be used to replace many uses of pre-signed transactions. You've probably heard about people saying, oh, we built this protocol where we pre-sign a bunch of things and then. So we pre-sign outcomes for a discrete log contract for a loan, or we pre-sign outcomes for an ARC pool unroll, or we pre-sign Lightning unroll transactions. Like there's a bunch of times, oh, we pre-signed, we shared pre-signatures, whatever. And in almost all those cases, CTV can reduce the cost and the coordination required to do that kind of protocol. because you don't have to pre-sign a thing. You put the CTV opcode straight in your script rather than creating a script with a key, pre-signing to get the same behavior. All right, that's CTV.
Now we bring in CHECKSIG from stack.
Yeah, and then we'll combine them.
Yeah.
So CHECKSIG from stack on its own is a very singular capability like CTV. CHECKSIG from stack has the ability to check a signature in Bitcoin on data other than a transaction hash. To kind of take a more user-focused, let's say, capability look at that, that enables us to delegate some decision about the content of our verification for Bitcoin transactions to signing time. So you could, for example, have a lock time check where instead of encoding the exact lock time into your script, you sign the lock time with another key, and that signature is used to verify the lock time is allowed to be used. So you could start out by locking some Bitcoin for 500 years, is like the default case, and then you could, at a later time, using that CHECKSIG from stack key, you could sign an earlier release point. And that's one way you can use it. And you can use it for also to sign to other keys. So you can sign in anything to your Bitcoin locking condition using CHECKSIG from stack. You're like, I originally coded it using a CHECKSIG from stack optionally to be after 500 years this key. But because I use CHECKSIG from stack, I can change that later using my special key to after 200 years, that key, and after 100 years, that key. Whatever you want to do like that. That ability to change the behavior using a signature at a later time. That's CHECKSIG from stack on its own.
So then we get into the combo of the two.
Combo. And the combo is actually, I think, where it gets really interesting. So CTV lets you verify the next transaction, which, as we talked about already, is fundamentally similar to signing to spend some Bitcoin, right? When you sign some Bitcoin, you sign the content of the transaction spending it. CTV asserts the content of the transaction spending it. Well, if you can sign something and you can assert the content of a transaction, the thing you can sign could be a CTV. And the unique thing about CTV and what makes it different than existing transaction signatures in that is that the CTV transaction doesn't say exactly which transaction output you're spending. And that is a necessary property of CTV, because in order for the CTV hash to fit inside of a script, when you make that script, it is impossible to know the identity of the transaction the output is going to be spent with. So you have to take that out to put the CTV assertion in a script. And then if you can sign that, now you can have what we call, or what I call, I think most people call, rebindable transaction signatures. I'll unwrap that.
Okay, yeah, because I actually don't understand this part. I've seen you say it before, like, this is where I hit my limit of being able to follow.
Okay, good. Yeah, let's unwrap it as well as we can and ask me lots of questions here. Right now, every signature used to spend Bitcoin includes in the data that it's signing over. So all signatures, technically what they sign is a hash, but that hash contains proofs of many parts of the transaction. And one of the parts that's always included is at least one previous transaction output, a UTXO. We talk in Bitcoin all the time about UTXOs. These are unspent transaction outputs. Just to dial it back one sec to make sure everyone is on the page with us. All Bitcoin exists in unspent transaction outputs. That's literally what it means for Bitcoin to exist and be spendable. When new Bitcoin is mined, there's a coin-based transaction that creates one or more UTXOs, and that is how the Bitcoin is created in mining. So all Bitcoin exists in UTXOs, and all transactions, all signatures, I should say, currently sign at least one UTXO. With CTV and CHECKSIG from stack, you can create a signature that signs a transaction, but not any specific UTXOs. Which means that same signature can be used to spend a bunch of different potential UTXOs as long as they have the same script lock on them, right? So if it has like CTV, CHECKSIG from stack, if that's the script lock and it's the same key, then that script or that signature is valid on any of those UTXOs locked with that same script lock and that same key. Why would you ever want to do that? the simplest reason, the simplest way to explain it, in my mind at least, is lightning symmetry. We talked before about how we used non-malleable transactions in segregated witness in order to enable lightning, because lightning chains transactions and you have to be able to not break that chain. No third party can be allowed to break that chain, or you can't apply the penalty and correctly resolve a lightning channel. Another way to solve that is to make it so that that chaining doesn't care if the transaction is malleated by a third party. So with CTV and CHECKSIGFROMSTACK, you can make a signature that doesn't care if the chain was changed by a third party. And so this was discussed all the way back before segregated witness as a capability Bitcoin could use. They're like, either we can fix malleability or we can make signatures that don't care about malleability.
So this is an old idea that dates back a decade now.
Yeah. Literally a decade, back to the original Lightning papers. So that's what rebindable signatures are, is they're signatures that don't care what the TXID they're spending from is. They don't care exactly what you TXO as long as it matches the script that's being executed to spend it. And that lets us, compared to non-malleability based Lightning, that is a more flexible construction. Now, it does require, I would say, a bit more tinkering with the protocol. It's a more open design space. Like non-malleability based Lightning is like, you do it this way. There's not really a bunch of different ideas. Once you have these rebindable signatures, there are many ways to design protocols. We've seen several designs even in the last year of kind of alternative ways to use rebindable signatures to make Lightning-like, to make payment channels that could fit into the Lightning network. So that's what we're talking about with rebindable channels. Did that clarify? Do we need to talk more about it?
I do understand it incrementally more. This is one of those things, with all things of Bitcoin. Sometimes I have to hear you explain it 3 or 4 times, then hear somebody else explain it, and then noodle on it for a while, and then I finally can, teach it in front of a class or something. So, okay. So, let's, for the average person, maybe whose lizard brain only lights up whenever it relates to how their JPEG is involved, let's go to CAT now, which is 5. As you say, there's 5 capabilities it unlocks. Each we could probably talk about quite a bit, but 5 is way more than 1 or 2 with the CTV plus CHECKSIGFROMSTACK.
Right. So with CTV and CHECKSIGFROMSTACK, you kind of get 1 each, and then a third one when they're combined.
Yeah.
And that's you get 3 out of 2 opcodes, and then with CAT you get kind of 5 in 1 opcode, just to contextualize this. Now, we should always kind of bear in mind that each of CTV and CHECKSIGFROMSTACK alone is more code than CAT, and so it's kind of weird in that way, but it makes sense if you think deeply about it. Bitcoin scripting is always restricting how something is spent, and it takes more code to make a more precise restriction than a less precise restriction. And so CAT is essentially a less precise restriction opcode. And so it takes less code to make that restriction because it's less precise. And because it's a less precise restriction, it enables more possible capabilities. That's not always going to be the case, but it's certainly a heuristic that kind of works. It's going to take more code to make a more precise restriction. So CAT's very little code, 5 capabilities, give or take. And there can be some bickering about the number there. The biggest thing that CAT enables that gets people to some degree up in arms is what we call granular introspection, meaning that using CAT, you can pull out any piece of the transaction in which that CAT script is executing and have it to do other work on. You can say, pull out the output script, make sure it's this. Pull out the input TXID, make sure it's this. Pull out the amount, pull out the time, whatever. Like you can implement check lock time verify in opcat. There are some restrictions on the ability to do that, but they're not that many. They're not much in practice. So that's the biggest capability that it does, is that granular introspection. And within that, some people say there's even sub capabilities where you can label each thing it can introspect as a separate capability, right? Like I said, cat gets you check lock time verify. That on its own is a capability. Cat gets you check output script verify. That's a capability. So there's a whole bunch of stuff within that granular introspection. And that's why we kind of, well, that is technically one capability. It's like the big one. Cat does introspection. But that is also very useful, very powerful. There's another proposal out there called check contract verify.
Yeah.
That
from Salvatore,
right?
Yeah.
Which basically is a way to make assertions about paired inputs and outputs. And like this script matches most of that script kind of things. It does a bit more than that as well. But you can see how opcat gets you that functionality or a lot of that functionality just because it lets you pull out the input script, pull out the output script, and make sure they're the same. So that's one big capability, the biggest capability of opcat. The reason people sometimes feel concern about that is that it opens up a bunch of different protocols you can build on Bitcoin. And we've seen some examples of this, right? Using mostly that introspection feature of opcat, Reindahl over the Taproot wizards was able to build an entire vault protocol. And when a lot of Bitcoiners look at a vault protocol, including myself, we see a protocol that allows you to make multi-step assertions in Bitcoin, multiple transaction assertions that kind of change with each step, right? You unlock the vault, that adds a time lock, and then after the time lock, you move it to the destination. That's an incredibly powerful set of behaviors that are enabled by the fact that you can introspect what's inside of a transaction. And so the fact that there are all these protocols, and especially multi-step protocols, you want to talk at some point about the specter of MEV, I think. This raises the specter of MEV, because similar to other blockchains that are out there that have multi-step contracts where you go through several transaction states to get through a contract, now you have contracts in Bitcoin that have multiple programmable states written by the introspection function of opcat mostly. Sometimes they also use other features of opcat and other capabilities, but really the introspection is the big one there.
Yeah, I actually think this is I actually kind of want to just go straight to this topic, which is I think this is probably one of the bigger pushbacks against Cat. One of the bigger. I don't want to qualify things as legitimate or like not compelling, but to me, this is one of the more compelling pushbacks against Cat, which is the scope of MEV. And for the listener, MEV is, I don't know, how do you define MEV, Reardon? And then, MEV. I guess if somebody's listened this far and they don't know what MEV is, then I don't know. What is MEV?
Well, it's funny because the original definition of MEV, as I understand it, was minor extractable value. Yeah. And then everyone realized that all the fees are minor extractable value. So really, MEV is maximally extractable value, maximum extractable
definition
value.
Now.
Yeah, so that's the one we now have. But the general idea with MEV is that it's something other than transaction fees directly that miners can get out of the transactions on a blockchain. So if you have two transactions in a row that take a fixed size input and create a fixed size output, but the transaction in the middle, let's say because you have rebindable signatures, isn't required to get to the third transaction, the miner can take out the middle transaction and they get more fees. Because instead of being inputs, outputs, inputs, outputs, it's just inputs directly to the final outputs. So the total fees extracted by the miner go up. So the miner took a transaction out, gained more fees for mining less transactions, fewer transactions, less data, and therefore gains. So this is the idea of maximally extractable value, is that miners can change things about the transactions they're processing to get more than what the basic fees would be if they just kind of naively stuck the transactions in a block.
Now you've done, I'm actually kind of frustrated by how few people I see actually trying to scope the scale or the modes of MEV or MEV unlocked by some of these proposals or potential from some of these proposals, Cat specifically, but then others. But you've done some legwork on this, more than most other people, I believe. And I think you might be one of the more insightful people on it. Now you wrote a piece about a year ago, little under a year ago, on Cat trying to scope like what it can and can't do. And if I can summarize, the TLDR was it can do many, many things. They don't terrify you though, as some other people will say. It's blanket unlock everything. You're like, no, it doesn't seem like it. It seems like we can kind of actually define them a little bit better, and being able to define, some of the concerns. I actually think made me and a lot more other people a little more confident and a little more open to like saying, okay, I personally am fine with cat. I like this idea, but although I don't think you actually right now say you prefer cat as a software, but I actually kind of throw at you the post-Capone Mev concern, which is he says that you can't prevent MEV, but you can limit the number of modes of MEV. Can you pull this apart and explain this and then offer your perspective?
Yeah, so I alluded in that direction what I was just saying of even with just rebindable transactions, rebindable signatures, rather, we already have added at least some MEV opportunities to Bitcoin, right? And I think it is either completely unavoidable or nearly unavoidable to add any capabilities to Bitcoin at this point without adding some opportunities for MEV. I think we're kind of at that point where if we're trying to change Bitcoin, it's going to have some additional MEV. So yeah, so post argument is that that's fine as long as we're adding kind of countable number of modes of MEV so that we can kind of prepare for them, so that we can say, all right, we're adding sandwich MEV by adding rebindable signatures. We can upgrade the Bitcoin node software that makes mining templates to capture that MEV. And as long as we can update the kind of open source, freely available mining software to capture the known modes of MEV that we know we're adding, and they're countable, so we can know, okay, we checked off that one, checked off that one, checked off that one, then it's kind of okay. Because the problem, MEV at that level is strictly a protocol problem. If you write a protocol that is subject to MEV, and that MEV is extracted from the users of that protocol, then you're hurting your own users. And that's fine. Bitcoin doesn't care if a bad protocol hurts that protocol's users. And no one should care about that. Like that's not our business as Bitcoin protocol developers. What does matter is if the protocols can make uncountably many modes of MEV, in which case we can't write Bitcoin node software that we can knowably check off and make sure that it's harvesting all of the MEV, or at least the vast majority of the MEV. If we can't like go through that checklist, then we're going to end up in a situation where some big miner is going to hire, a team of like 20 professional software engineers to build a MEV harvester. And they're going to have a proprietary MEV harvester that gets more value out of every block that they mine than all the other miners. And you can kind of start to see where this starts to hurt Bitcoin's decentralization, because now we've got Mega Miner, whoever had the most money to throw at software engineers at the start of the MEV world, now gets to grow bigger and bigger because they get the most revenue per block. So that's what Post is concerned about, is that if we add opcat, we're going to have uncountably many modes of MEV, and then some big miner will hire a team of software engineers to harvest that, and they're going to get leapfrog ahead in mining.
Do you agree with that, or where do you fall on this discussion? Or maybe you feel that there's we just don't know about certain dimensions of this. Like what I understand about CAT is like with the things we've been able to scope are manageable, but there may be additional things that we haven't scoped yet. I don't know. Where do you fall on this?
Yeah, my take, I would say, is, well, it's twofold. One, and Post and I have talked about this, and he's just less confident on this being sufficient than I am. One, Bitcoin is slow and limited. And it's a UTXO coin, not an account coin. And that combination of things limits some of the MEV leaking protocols from being built fully on Bitcoin, right? It's hard to build a protocol that works when you only have finality every 1 minute to 2 hours. Other blockchains that have had the bigger problems with MEV tend to be 10, 20, 12, whatever they are, second blocks, not 10 minutes on a highly variable time scale. So that's one thing. And then the other thing is that Bitcoin is a UTXO coin. We talked already in this chat about UTXOs and how each amount of Bitcoin exists in kind of this discrete piece of a transaction output, whereas a lot of other coins work on accounts. What's the difference? Why does it matter? Well, UTXOs are created and then destroyed. They're not a durable thing. So you can't in the same way have updatable state on a UTXO. You can get something kind of like updatable state with opcat based protocols or other opcode or capabilities, but it's not the same thing as a account with a contract associated with it that has updatable state. So those two things reduce the usability of MEV, and that does reduce my personal concern about it. The other thing is that opcat doesn't do everything. For example, it is prohibitively difficult with opcat to do big number multiplication past some threshold. You can't do true big number multiplication. And one of the features that almost all of these protocols that leak significant MEV on other chains use is multiplication. Because when you're doing pricing, which is like the most common way you end up leaking MEV is through some kind of a price function in a script. You kind of got to multiply stuff. You got to multiply amounts by rates, by et cetera. And if you can't do multiplication on sufficiently complex numbers, you're limited. And so there's this nuance of you kind of can do multiplication with cat, but it's multiplication made discrete. You have to kind of chop off some of the details of the multiplication and make it a less precise multiplication, which then fundamentally, well, it may still be a very large number, takes you into the countably many ways of MEV because now you have kind of atomic units of what multiplications you can and can't do. Because it's not a linear multiplication, right? It's a discrete, like this one, this one, this one are the values you can have in this protocol. So those things to me take my concern level about the risks of MEV from cat down like to a low enough level that I would not fight against cat. I'm not worried about it. I don't think it's the best thing for Bitcoin. As you said, I'm not like a cat supporter. I'm not a cat proponent. I'm also not worried about it.
Which is really helpful because maybe we can now step back from the specific details and just kind of reflect on the current soft fork discussion because I feel that there's been a lot of progress towards a productive conversation in the past year and a half. And just depending on the month or the week, sometimes we're in various states of discussion or various like on the spectrum of consensus and what is the more favorable hot thing that we're talking about. But like, I think, I mentioned Post Capone last fall. I had him on this podcast and I was reflecting like, there's just not that many good cat critics who can offer productive insight to it because it is compared to the other software proposals quite broad. So it's very difficult to critique something which is a broader comparatively. So I guess like let's reflect on the current state of consensus. You have you proposed this framework, which I assume at our conference you'll elaborate more further to a more targeted technical audience where you can really get in the weeds on it. I'm actually struggling to ask like the next question. What do you hope happens next? How do you think we can incrementally improve the discussion around this? And then what do you hope actionable steps in the developer discussion look like over the coming months?
So I think my hope is that we can continue, as you said, we've been making progress, but we can continue improving the quality of the conversation. And so I've written a few posts. You mentioned my opcat and the Infinite Nothing article, but I've also written others about words. And we have this real problem with words in this space. It'll be the first time I just use the word recursive in this conversation because I don't think it's a helpful word. And that's why I used words about with cat, you can have multi-step computable state.
Yeah.
the quieting is a more useful word, but it's a more esoteric. So I don't like that either, really.
Yeah.
I mean, personally, I like it. I don't think it's good to talk about. We've been having this problem with words. And so I've realized, in particular, when Matt Corallo and I have conversations, we don't use words the same. And so it can get very frustrating. So one of the things I'm hoping is that we can continue improving the discourse by working to find words that have clear meanings, so that we're not talking about different things while using the same words. So that's one thing that I hope for, is that continues to improve. In terms of the broader, like, what are steps or where are we going with the soft fork conversation? I think the Taproot wizards and their kind of army of cats, meow, has done a lot of good in kind of kicking people in the pants, getting them up to actually have conversations about this stuff. And my hope is actually that they kind of cool their jets a little bit, and that we can then use the energy they've injected of having the conversations, but now in a more precise way. Especially the loud people over there at Taproot Wizards, they tend to twist their messages in a way that makes them harder to take seriously. And I talked to Christian Decker, who's just a very wise person. He's been in the space a long time. He's lost more Bitcoin than anyone. And that makes him, I think, kind of wise in how he reflects on things. And he said, we need to stay away from salesmanship. And so I try very hard to stay away from salesmanship. I don't always succeed. I get frustrated at times, like anyone. But I think the more that we can stick to kind of concrete technical conversations and away from either salesmanship or, for lack of a better word, I don't love the word, but hysteria about things. Like I said, I recognize the concerns about MEV that Post has, but I'm not like, I don't feel endangered by them. And so I can calmly look at them and say, oh, I get what you're saying. I get how CAT, with these multi-step protocols and with some limited multiplication, this can enable certain MEV risky protocols. But I don't think it's going to hurt Bitcoin, because it's going to be contained within certain protocols. It's not going to be so hard to harvest that miners are going to be getting a huge advantage by harvesting it. And so that's a nuanced take. I'm not like all the changes, and I'm also not, oh God, don't touch it. So I hope we can have more of that style conversation, in short.
That is I feel like it's a really good, like, kind of capstone to bookend this chat. Reardon, where can people go to find you? I feel like this is not the last conversation we will have on this podcast, especially if I do this, if this makes it more than one calendar year of Bitcoin season 2. So where do people find you? And what I would say, if you could recommend one thing that the listener reads after this, what would you recommend?
Yeah, you find me on X mostly, ReardenCode, ReardenCode. I'm also on a lot of other places. I'm also ReardenCode on Telegram. Watch out for scammers, obviously, I hope. What would people read? I've been lamenting, actually, to be honest, that there has not been a new Bitcoin book that's updated for Taproot and ordinals and et cetera. So I don't have a good answer there. I wish I did. I'll throw out that if you want to think about better Bitcoin future, a better Bitcoin future, broadly speaking, both ARC companies, ARC Labs and Second BTC, are putting out a lot of great content that I think has given me some new ways to think about Bitcoin. So I would check out both of their websites. They're continually upgrading their developer documentation and user documentation. And whatever you think about ARC itself as a protocol, the way they're talking about Bitcoin, I think, is refreshing and helpful. So, yeah.
All right. You've got it. Reardon, thank you so much for coming on Bitcoin Season 2. And I will see you in person at opnext.
I can't wait.
If you haven't got your tickets to opnext and you're listening to this, you got probably 36 hours. opnext.dev, DEV. Otherwise, thank you for watching Season 2. See you all next week.
Thank you all.